Let's start with a number. $1.3 trillion. Yeah, that's the projected value of the generative AI market in less than a decade. So, this isn't just another tech trend, it's a massive, monumental shift. But how does any of this stuff actually work? Okay, let's dive right in. Welcome to The Explainer. Today, we're going to pop the hood on generative AI. Think of this as your user's guide. We're going to break down the engineering behind all the magic, step by step, to show you how these incredible tools are really built.
All right, so to really get this, we first have to understand the huge leap that generative AI represents. It's a fundamental shift, really. We're moving from an AI that just labels the world around us to an AI that can literally create entirely new ones.
For the longest time, AI has pretty much been what we call discriminative. You show it a photo and it answers a simple question, like, is this a cat? But generative AI just flips that whole script. You give it a prompt like, draw me a picture of a cat, and poof, it makes something brand new. It's really the difference between an editor who just polishes what's already there and an author who creates something from a blank page. So how in the world do they learn to do this? Well, these models are trained on just these mind-boggling amounts of data: text, images, code, you name it. But here's the key. They are not just memorizing it. It's more like an artist who studies thousands and thousands of paintings. They're not learning to just copy a Monet. They're learning the idea of impressionism, the patterns, the relationships. It's absorbing the very essence of a cat, so it can then create a new cat that has never existed before. So we know what it does, but how does it actually think? Let's take a look inside the AI mind, so to speak, and do a quick tour of the core architectures, the different kinds of brains that are powering this whole new creative revolution. First up, you've got something called generative adversarial networks, or GANs for short. Now, the concept here is kind of genius. You have two neural networks that are basically locked in a fight. You have the generator, which tries to create fake stuff, and then you have the discriminator, which tries to spot the fake from the real thing. The best way to think about it is like this. Imagine an art forger and an art critic who are in a constant competition. The forger, our generator, keeps making fakes, and every time it does, the critic, our discriminator, has to get better at spotting them. This endless back and forth forces both of them to improve like crazy, and that's exactly how GANs learn to produce those incredibly realistic images we see. And then you've got the architecture that really changed the game, the transformer. Its superpower is that it doesn't have to read text one word at a time, in order. It can look at an entire sentence, or even a whole book, all at once. And it does this using this brilliant idea called self-attention, which helps it understand the relationships between all the words, no matter how far apart they are. This is the engine that's under the hood of models like GPT. But what does that, self-attention actually mean in practice? Let's take a sentence like this one. We read it, and our brains instantly know that it refers to the bee. But for a machine, that's actually a really hard puzzle. So how does it figure it out? Well, this is where that self-attention mechanism kicks in. When the model gets to the word it, the mechanism lets it scan the entire sentence and assign a high attention score to the word bee. It mathematically links it back to bee, and by doing that, it learns the context. It basically solves the puzzle and starts to understand language in a way that's much more like how we do. Okay, so we've got these incredibly powerful but kind of raw AI brains, but how does an engineer take one of those and turn it into a useful app that you or I can actually use? Let's walk down the assembly line. So, first thing you have to know, a model doesn't understand words, it understands math. So the very first job is to translate our language into its language. And that happens through this 4-step process. You break the text down into little units called tokens, you map them all to numbers, and then you organize everything into nice, uniformly sized batches. This is the fundamental prep work that turns messy human text into something an AI can actually chew on. So once the data is ready, you can start shaping what the model knows. A base model like GPT, it's a generalist. It knows a little about everything. To make it a specialist, engineers use a process called fine-tuning. It's kind of like taking that genius who knows everything and giving them a very specific textbook to study.
say on legal contracts or medical research. This makes the AI an expert in one specific area, and it's way more efficient than retraining the whole thing from scratch. But even a fine-tuned model can have outdated information. I mean, what happens when new stuff comes out? It's a huge problem, right? Well, that's where this really clever technique called retrieval augmented generation, or RAG, comes into play. When you ask a question, instead of just using its own memory, the system first goes out and retrieves fresh information from somewhere else, like today's news articles or a new company document. It then augments your original question with this new info, giving the model the up-to-the-minute context it needs to give you an answer that's actually accurate and current. Of course, none of this would be practical for most people if it weren't for an incredible set of tools. So let's take a look at the software that has basically democratized AI development, putting these powerful capabilities into the hands of way more engineers than ever before. At the base of all this, you really got two major powerhouses. There's PyTorch, which is what all the researchers love. It's like a flexible, experimental lab for playing around and innovating fast. And then you have TensorFlow, which is more like the factory floor. It's built for scale, for deploying these tough industrial-strength apps that can serve millions of people. But here's what's truly revolutionary, how accessible all of this has become. Thanks to platforms like Hugging Face, a developer can run a super powerful pre-trained model for a really complex task like analyzing sentiment with just 2 lines of code. I mean, what used to take a whole research team months of work, you can now do in minutes. It's a massive, massive game changer. All right, for this last part, and it might be the most important one, when you're building machines that are this powerful and this creative, it comes with a huge amount of responsibility. We have to be really intentional about what we teach them and what values we bake into them. Responsible AI. It all starts with the data. You've all heard the saying, right? Garbage in, garbage out. Raw data from the internet is messy. It's filled with typos, slang, and just irrelevant noise. So the first, most critical step is cleaning it all up to find the actual signal in all that noise. This isn't just busy work. It's literally the foundation for building any model that you can actually rely on and trust. And even with perfectly clean data, engineers have to constantly be on guard for several key risks. You've got hallucinations, where the AI just confidently makes things up. That can destroy trust. You've got bias, where the model absorbs and then amplifies the worst stereotypes from its human training data. And on top of all that, you have the huge challenges of protecting user privacy and, as we saw, making sure a model's knowledge doesn't become dangerously out of date. And so that really brings us to the final thought here. For the very first time in history, we are engineering machines that don't just calculate, they create. And that power, it brings with it this profound question that goes way beyond code and algorithms. We're building machines that create, so what should we teach them to value? That is the challenge and the opportunity right in front of us. Thanks for joining this explainer.